Up on my workbench tonight I have an Aurex by Toshiba cassette deck. Nice fluorescent display here for our VU meters. And this unit's not doing anything. So let's take the top off it and see whether it's fixable. Now I know what you're thinking. You're probably thinking, oh, it's going to be the belts. And if you're thinking that, you'd probably be wrong, because I think the belt in this thing is probably okay. Oops. Here, I'll just turn this thing from down below here if I can get my finger in here to turn the flywheel. But I think this belt is probably okay. You see? So, we have no power. We have our display power, but we have no control power, no motor power. So we have a power issue on this unit. Let's see what's going on. I'll get the meter out here and we'll just do some measurements. I don't see any obvious switches to detect if there's a tape in or out on here. We'll check the voltage for the motor and see if we've got any voltage getting to the motor. And I'll just measure here, and there's nothing. There's no voltage to the motor. So the motor's not going to try and turn if there's no voltage. So we have to investigate and see why it's not working. Is it a control problem or is it a power supply issue? I don't know whether this motor is supposed to run full time on this unit or whether it only runs when there's a tape in it. So the first thing to do is to give this thing a good look over and just see what controls it. I see that there's a couple of solenoids back here, one here and one here, that would control the mechanism. So it's going to be, they are going to trigger a couple of cam gears to rotate to raise and lower the heads on this design of a unit. But still, we should have control to control the solenoids to try and operate the mechanism. But the motor needs to be running for that. There's something I totally missed on this unit when I first looked at it. It has a little vacuum fluorescent display tape counter. How cool is that? So we're just going to check some of our voltages from our voltage regulator and see whether our regulators are working. So just going to ground my meter probe to the chassis, and we'll just take some voltage measurements here. So here's one of our regulators here. We've got 18 volts on the collector, 6 volts on the base, and the emitter has 6 volts. So that one's working. And this one here is our minus 16 volt. We have minus 8 on the base, minus 7.6 on the emitter, so that one's working. We'll go to our next one over here. Our collector's got 18 volts on it. Our base has 12.2 and our emitter has 11.5, which is good. This one here, we've got minus 18 volts. We go to the emitter and we find that we have minus 11. And of course the base will have about minus 11 or minus 12. So those regulators are working. I'm sure that there's going to be a 5 volt supply for this thing somewhere, because the logic circuits are typically going to run off of 5 volts. They might run them off to 6.25, but typically they want about 5 volts. I got nothing for the motor, as you can see, no motor voltages. I have 12 volts on one side of the lamp, or minus 11 volts on one side, 0 on the other. There is actually an incandescent light bulb in the front to light up the tape. I believe all that does is light up the tape. It might be used in the auto stop circuit. So it could be the light bulb that's causing it. And with nothing showing on the photo sensors, might be shutting it down, but I don't think so. I don't think that's what the case is on this, because usually they have infrared photo transistor array with a photo transistor and a LED, and they use reflective strips. That's usually what they do on these things. And there is a connector down here marked reflector, which would be that to detect if the tape spool was turning. I got 1 volt and 0.1 and 0.0. So if I put that down there, if I turn one of the take-up or supply spools, I probably should see. Yeah, there we go. So we know the reflector's working, you see? Now it goes to 6 volts. and down to 0 on the take-up spool. So this is how the auto stop works. If the take-up spool stops, normally when it's running, you've got a voltage going up and down. And when the tape stops, that voltage swing stops, and the microprocessor knows to shut it down. So it's not the light bulb that's gone bad, as would happen on some of the old VHS machines that used an analog or used an incandescent light for their tape end sensors. And when that bulb would burn out, the machine would go into a shutdown mode, and you couldn't do anything until you changed that bulb. Ask anybody who had a VCR back in the days that used that incandescent light how much the service departments charged to change it, and it would blow your mind. But it was not common to pay upwards of $80 to $100 to have a light bulb that had to be soldered into the circuit replaced. But that's not what's controlling this one. We'll check the voltage to the main micro, and I find that I have 6 volts. So this is running off 6.25 volts. So microprocessor has power. The next thing we need to check is we need to make sure that our key scan has got power, because our function keys, they have to be able to signal the microprocessor when you want to change modes. And typically how they do it is they'll have a resistor voltage divider network. When you close a switch, the different switches will go through a different resistor and change a voltage that is being measured by the microprocessor. So I believe this is the cable here that connects that. Let's just turn this around so you guys can see it. Actually, I think this is probably the remote control. There's a little remote receiver there for the infrared remote. I think the key switches are probably in behind here. I'm looking at this thing and I'm like, what the hell? You know, it's got a remote receiver here, and the wire is going back to the circuitry, and I checked these ones here, and these are just going to these little lights. And what the hell's going on here? Check this out. I've never seen one of these before. You guys aren't going to believe this. Maybe some of you have seen this before. I have never seen this before. It has a remote control. The key buttons are remote controls. This thing needs a freaking battery in it. I'm thinking we have a remote problem with this. The frequency is not right, more than likely. I've got my scope tied down to the preamp output, which is right down here. There's a little test point that's right in here, and that is the preamp output. And if I take just a regular TV remote control and I point it into the front of the set, watch the waveform. See? So that tells me that the preamp is working, it's receiving a signal. When I take the original remote control and I point it, I'm just seeing the background noise. Even though when I look at this with my camera, I'm getting an output from here, it's not giving me the right pulses. So maybe the crystal inside here is broken, but we definitely have a problem with this handset. So I think when I can fix the problem with the handset, we'll fix this problem with this tape deck. Yikes. Look at the mess in here. Someone's obviously been into this remote control at some point. Let's try and clean this thing up a bit. The most likely cause, other than debris on the circuit board, which is causing shorts, is going to be that little ceramic crystal there. It's a standard 455 kilohertz ceramic oscillator, and that is the most likely cause of a failure on the remote control. What happens is people drop them and these things break, and that's why a lot of times they'll put them down with a dab of glue, because what happens is someone drops a remote, this thing smacks up against the board and breaks the crystal inside it, and then the frequency is different. But fortunately, 455 kilohertz is a pretty common frequency, and I bet you if I go through a half a dozen of the or so remote controls that I've got here that are scrap, I'll find one that's the same frequency. But let's just clean up this mess on the back of this board here first, and then we'll check that out. I'm pretty sure this mess here was someone let batteries go corroded in this thing at some point, and that's what damage it did. It's gonna put the batteries back in this thing right now. I just want to see whether when I press any keys, whether the 455 kilohertz ceramic oscillator is actually working. Show you something here. Okay, I've just done a little bit of work on this remote control. I think our crystal's okay. When I press some buttons on here, watch this display, and we get a response. Pause. Let's try play. We had a play signal there for a minute. Play. Come on, go. It's just a matter of repairing the traces on this board. You see it's responding. It's playing now. There we go. As you can see, I don't have anything hooked up here. I don't have a tape with music on it. I just have a blank tape in here now, and I don't have it hooked up to my amplifier. We'll put a music tape in there and see what happens. But as you can see, my tape counter is moving. The tape is turning. Let's try a tape with some music on it and see whether we get any sound out of this thing. Well, we have, as you can hear, we have sound. It's work in progress, but we know that it's working. Our little light on here that says we're in play is lit up. Not all the buttons on this remote are functional, but looking at the condition of the circuit board with the traces that have been corroded here from battery leakage, it's understandable that they're not all functional, but we'll get them going. Okay, so we know the problem with this unit is the remote control unit has been damaged by battery leakage. So I'm going to try and repair the board here, and we're going to try to repair the damaged traces here and see that will make all the buttons work. Some of the buttons now work on it, others don't. So I'm going to get some copper out, and we'll overlay these traces with some copper wire and reconnect the damaged traces. And hopefully that'll get this remote functional so that I can have a working tape deck again. So the first thing I'm going to do is I'm going to go over the connections, just reheat all the actual component connections and reflow some solder onto all of them, and then we'll go about actually putting wires over in place of them. So the first thing we're going to do is we're going to clean the board up here as best we can, get all the corrosion off. I'm just using good old 99% isopropyl alcohol. It's a good general purpose cleaner. We'll just clean the traces here. First of all, to help me see where the traces are, and secondly, clean any of the crap off the board that's going to prevent rosin and solder from sticking. So we'll get all this damaged area cleaned up, and then we can go about repairing the bad traces. Now what I'm using here for jumper wires, I'm just using standard Ethernet wire, and there's no point in trying to strip a little bit off the end. All we do is just put the soldering iron up against the end of it and heat it, and that'll melt the plastic enough, and we can tin the end of the wire, and then we can just bridge over the damaged section of circuit board. So in this case, I'm going to put a jumper wire to this switch here. And then we're going to trace that through the other side of that wire. It goes right over here. So we'll solder this one down to that terminal. And that's how we're going to bridge over all the damaged sections of this board, just from one point to another. There's not that many traces that are actually bad on here, but all the ones that are blackened from the battery acid are going to have to be bridged over just to ensure a quality repair. But I think once we get all of the connections soldered over, unless the switches themselves are damaged, which they probably are okay, then we should be able to restore all the functions of this remote control, and then I can look at calibrating the speed and so forth, and checking the alignment of this deck, and we'll get it up in ship shape again. So I am making progress bridging all of the damaged connections on this board. This is the main reason why battery manufacturers tell you don't leave dead batteries in your battery operated devices, because batteries can and do leak corrosive material, and it's going to attack the copper on any circuit boards or wires that it comes in contact with and corrode it. And sometimes this damage cannot be repaired. I'm trying to repair all the damage on this one because there's no chance that I'm going to find a replacement remote control for this tape deck. And unfortunately, the design of this deck is they don't have any backup buttons on it. So if the remote is broken or lost on this tape deck, it is useless. So I have to repair this thing at all costs if I expect that this tape deck is going to be usable again. I'd really kind of like to make this deck usable. It's kind of a cool looking deck with that fluorescent tape counter and the vertical vacuum fluorescent display VU meters. It looks cool. I mean, this is a nice looking piece of equipment, and I'd really like to make it operational again, and that I can find a home for it. But it's kind of tedious because I'm having to, as you can see here, basically overlay every little strip of copper that's damaged, and there is some extensive damage. There's a lot of open connections here that I have to basically scrape to figure out where it goes, because some of it has been corroded to the point where you can barely see it. Figure out which connections go to where. I'm working with a magnifying glass here, my old TV camera lens, so I can see what I'm doing. But I have full confidence that I will have all the functions. Some of the buttons are working on it now, some of them still aren't. I have full confidence that I will get all the buttons operating on this thing soon. Okay, I've got my, I think all my connections are pretty good here. When I press buttons on the remote, we'll see on the scope that we actually are sending a signal, but the deck is not always responding. And what I found is there is a frequency adjustment inside the deck. I'll show you where it is. We're going to just tweak it a little bit. I think maybe our receive frequency is just maybe just a little bit off for the remote. So down inside the deck here, there's a little coil, a little transformer. This is I think the frequency adjusts for the remote receiver. So we'll just give it a bit of a turn. There's a test point that we can actually test this is the receiving circuit here. This is the preamp, and this is the test point for it. Let's just see if that remote works after tweaking that control a bit. So again, I turned it about a quarter of a turn counterclockwise. Either way, you just have to try one or the other to see if it works. Let's just see if this will actually work now. So press the play button on here, and there we go. Oh, stop. Let's try rewind. Rewind, there we go. There we go, rewind. Stop. Maybe we're still a little bit off. Let's just try tweaking that control just a bit more.
I'm serious, if you don't answer this dadgum phone, I'm coming down there and kicking your ass so hard you have to clear your throat before you fart.
So I put the remote back together and it doesn't appear to be working. So I wanted to see whether we're actually getting a signal out of this thing. I have my camera here in night shot mode, so we're able to see if this thing's actually putting out a signal. And whoops, I hit the playback button here. Where we get out of play. Okay, night shot. Okay, we can see that this thing is actually sending out a signal always. So I guess one of the buttons must be, well, at least we know the buttons are working. I'm just trying to see which switch, or we have a short here. Something is making this thing send out a signal as soon as I put it together, as you can see on my screen here. If you have a camera that's got night shot, you're able to do this. If I turn the night shot off, of course, you can still see a little bit of flicker there on the screen here. That's the infrared cut filter is actually removing most of it. But if we turn on night shot, you'll see the camera actually removes the infrared cut filter, and then you're able to see it. But we have a problem here with this remote. Now that it's back together, we're actually emitting a signal. So we must have a short somewhere that's giving it the equivalent of a switch that's short, that's closed. So let's get it apart again to see why it's sending out a signal constantly. I had all the buttons working when it was apart. When I put it together, it stopped working. So I grabbed my other camera just so that we could actually see the light from the infrared diode. What I'm thinking is it's probably one of my jumper wires got pinched between the back cabinet and the circuit board and it pushed through the insulation. So what I'm just going to do is I'm just going to put a layer of insulating tape between my repair wires and the board itself to prevent any shorts, and we'll see if that fixes the problem. So basically I've just provided insulation between the different wire layers and the board to try to prevent any short circuits when the remote is reassembled and the screws placed in it. Because what I think happened is when I tightened it together, it compressed one of the wires and punched through the insulation. Play. Stop. Fast forward. Play. Rewind. It's got an annoying beep, but I think you can turn it off by pressing that button there. Stop. Stop. Play. There's not music on this entire tape. It's my record test tape. But we'll get our alignment tape in here momentarily. But there is some music on here. So I guess that goes in. That can sit in like that, and then it can be controlled as a deck. Let's get my alignment tape and we'll clean this thing and do an alignment on it and see how it sounds and check the speed and so forth. As you can see, the head doesn't look to be in bad shape at all. I don't see any wear, any excessive wear on there. Let's just get the a Q-tip here with isopropanol alcohol and we'll just clean it. And we'll get our speed test tape and check our speed on this using the guitar tuner. Here we go with our 440 tape. We're a little bit sharp, so let's just adjust our motor speed here. If I can. There we go. Now, Mr. Guitar Tuner, says I'm right where I'm supposed to be. I have recorded on the other side of this tape a little higher frequency for doing the head azimuth. So to align our azimuth using an oscilloscope, what we do is we connect our two channels to the two outputs. So I've got one channel to the right output and the other channel to the left output, and we put our scope in a mode called XY. And what XY will do is one channel will cause the scope signal to deflect up and down, and the other channel will cause the scope to deflect left and right. When we are perfect with no phase error, we will have a perfect diagonal line across here. If we have a phase error, it could come up at any different angle, even a circle. If we have a 90-degree phase error, for example, we'll get a nice circle. So what we're going to do is we're going to play the tape. It's a 3 kilohertz signal. We're going to play this tape and we're going to adjust the azimuth of the head to make this line perfectly diagonal, like this. As you can see, we're not perfect. We have a bit of an alignment problem here. So I'm going to adjust the head azimuth. Just put a screwdriver and adjust the azimuth of the head ever so slightly to try and make this a perfect straight line. And as you can see, as I go out and come back, you see that? I'll zoom the camera in so you can see what happens. So this is what we want. We want the two sides to form a straight line, like that. And what we'll find is we should have equal spacing. There may be a little bit differential between one and the other because the gain may be a little higher on one side than the other, and it actually is. I'm seeing a little bit higher signal on one side than the other, which we can adjust the playback amplifier to balance that. But what I want to do here is I want to adjust the azimuth to try and make this a straight line. Obviously, as I'm going out, as you can see, now we're 180 degrees out of phase. We want it as flat as we can, like that. Now, it's never going to be perfect because analog tape is just that, especially cassette tape. Nothing is ever perfect on cassette tape. This is one of the reasons that Sansui came out with their direct-o-matic cassette loading system. If you notice, if I just so much as touch the tape, you'll see an effect on the scope. See that? Just pressing on the tape. So if you have a cassette mechanism that the little springs aren't holding the tape firmly, it'll actually affect the alignment just by moving the cassette housing like that. It'll change it. So that's why the direct-o-matic system was so revolutionary, is because it eliminated this plastic cassette holder, which can cause alignment variations, alignment errors. Since my level is a little bit off, I'm just going to adjust. I know that it's recorded at 0 dB, or actually it's recorded at +1. And on my left channel, I'm seeing right at 0, and I'm seeing +1 on my right channel. So my left channel is just a little bit low. And I have to go back, and that was the end of my tape. We'll try that again. Let's go to our level adjust here. And as you can see, we can bring the levels up so that they're both about the same. That's just our wandering cassette. Okay, let's try and tweak this thing just a little tad more here, try and get a little more true. Cassette's a crappy format, especially a cheap deck like this. This is not a real high-end deck. It's pretty darn close there. And I'm looking at our signal level with respect to the center. And our levels here on both sides are about equal. I'm just looking at the gradations here. Yeah, oh, that's our tapes at the end again. That was fluctuations there where they were just the tape is not perfect. It's an old tape. What I did, I make these tapes myself. I have a set of alignment tapes that I bought, 25, 30 years ago when I was in the business. And I use those tapes to calibrate my Techniques RSM 275, as that particular deck is the deck that I have that's got the best transport. It's a 3-motor direct drive system, so it's the most accurate for speed, and it's the alignment is absolutely perfect on that. So I've used my factory alignment tapes to align my reference deck, and then I've used that reference deck to record my tapes that I use in old machines that I'm restoring. That way it keeps my expensive alignment tapes that I have, keeps them out of decks that could potentially chew them up. Okay, this one here is ready to go back together, and it is now working. I hope you enjoyed the repair video of this. It's a Aurex, which is Toshiba, and it's a PCG8AD. I hope you enjoyed this video, and we'll catch you again real soon on the next one. Bye for now.